Welcome to the second screencast for our quick introduction to Greenfoot, and we're going to look into the act method of the actors, and most importantly we will make our actor move and turn. Move and turn are methods that are inherited from the parent class actor. One good starting point is to check the documentation of the actor class. So let me bring that into our screencast window. There we go. So all these methods, all these codes, you inherit from the actors, which means you get access to loads of methods that have been written by, well, very experienced programmers. You cannot break them. When you inherit those methods, you haven't got access directly to the raw code for the method. You just well, the keyword is inherit, and you can make use of this method in your code. You can add to them, you can rewrite the method if you want, but if you do so, that will only apply to your own class, not to the parent class. So you would not have, it's not possible in this way to break somebody else's code that would use the same methods. Which is one of the big advantages of object-oriented programming. Back to what I want to do in this tutorial. So this is the move method. It's going to take one argument, the distance, how far you're going to move in one step of a program. Move the actor in the direction it is currently facing. Then the other method we're going to use is turn, in order to turn it by a specific amount of degrees. We'll keep it simple by just going plus 180 degrees to make our spaceship go and then turn around when it reaches the edge. So now, time to do a little bit of coding. Right click on the rocket class in the actor panel to open the editor. This is showing on my other screen, so I need to drag it into the screencast. Here we are. So by default, when you create a new class, it comes with this skeleton code, and in here you've got the act method, which right now is empty. The act method gets executed every time our whole scenario goes through one step of a program. So every actor and the world itself would all at the same time run their codes of the act method, and then it would iterate a second time and so on until you stop the scenario. Now let's add some code in here. So what I want to do is to see my rocket move. So if I ask it to move, let's say 4 steps. Move 4. Now this is Java, so you need to add a semicolon at the end of every instruction you give to your program. I can compile my code, no error. Now that I've done that, compile my words. Oh, my rocket isn't showing, so let's bring it back and run my code. So the rocket goes all the way until the edge of the world, and then it stops. So this is when I need to make it turn. So to make it turn, I'm going to use this instruction, turn 180, so that's going to make our rocket turn around. However, I don't want it to turn every single time the act method is called. I want it to turn when it reaches the edge of the world. So, well, the edge, that means on the left or on the right. In Greenfoot, the coordinate for our screen, it's same as in App Inventor. the reference 00 point is the top left corner of our screen. So the left edge, it's easy. It's going to be 0. The right edge of the screen, that is a little bit more difficult. We're going to have to ask the world what this number is. Well, let's take a shortcut. Let's have a look into our space world code, and here it tells us the dimension of the image we're using, 600 by 400. So we're going to take a little bit of a shortcut first before we improve our code. So now I need an if statement, and we're going to use as a condition. So in Java, your conditions, you put them in between brackets. So if I'm going to use another method that we inherit from actor. I'm going to use a method to check the position of our actor right now. So this is the get x. No arguments, but I still need to put the open and close brackets. So if get x is, let's say, less than 10, if we're getting close to the edge, and then I want an or, get x more than, so the width of the world is 600 minus 10, that's going to be 590. So I only want to turn when I get close to the edge. Now if I'm at the edge, I want to turn, and then the code that gets executed for this if statement, I have to put it in between curly brackets. And by definition, I'm going to make it look like this. Now this is starting to look a little bit messy around here, so let's look into our edit menu. Oh, the pop-up window has appeared into my other box. I want to access auto layout. Now for some reason the pop-up is in my other screen, but I just click on auto layout and then it's arranged all the code for me. I can't run this because right now I have an error. I've used the keyword OR for the logical OR operation, but in Java it is not written OR. Instead we've got this vertical sign, which on my English keyboard is just left of a Z and above a backslash, and I need 2 of these. Now you'll notice that the white I had here has now turned into purple, so the Greenfoot environment recognizes that this is all one block of code. It looks a lot better, which is a good sign, with these little colored blocks to show us where the structure of our program. So I've got my if statement there. Let's try to compile this. Getx, it does not know getx. Alright. Now the way around this is to use the this keyword. So getx refers to the object that this act function belongs to. So to make sure Greenfoot understands that, I'm going to type this and then a dot. So this is the getx function for this object. And then same thing here. And let's try to compile this. Oh, I've actually forgotten to open and close my bracket to signify that this is actually a method call, a call to a function that's attached to the class for this object. This is it, it's working. So let's have a look at my game now. I add a new rocket and I run the code. And here it is, it reaches the edge of the world and it turns around. Excellent. Right, next we're going to get our rockets to drop some bombs on the bottom of our screen in our next screencast.